Okay, in this video, we are going to explore functional programming and see how we can use some of the patterns that are more common when you write your code in the style of functional programming, and we'll refactor our code here to adhere to this paradigm. So functional programming generally involves, it's a style that uses things like higher order functions, closures, immutable data, and pure functions. And so these are, and other paradigms, these are some of the concepts that we have gone over in the chapter on functional programming, and we're going to take a look at them, at least some of them. And that gives us an opportunity to both practice and review the concept here. What I want to say right off the bat is this style of programming that we wrote the code is perfectly fine. There is absolutely no reason for us to go and change it. It reads well, it works well, and this is just an example of looking at the same code and writing it differently, just for the sake of experiencing different style of program. There is no good reason for me to change the way that I'm writing my code right now and refactoring the application to adhere to a different paradigm. But that's it. Let's go and take a look at some of the things that we can bring to the table here. So something that you're going to see in a lot of places is that we work with arrays. So part of the state of the app is this ToDo's array, and we have several places that we iterate over the elements to filter the values, to do something with those elements. And in JavaScript, arrays have built-in functions. Those built-in functions, they enable a more declarative style of programming, and they rely on some basic features of functional programming paradigm, which is to pass a function to another function as an argument. A function that takes another function as an argument, or it returns a function, is called a higher order function. So let me give you an example of it. Let's look at this for loop as an example, right? So we want to go over every element of filtered to-dos. We can take this, and rather than taking this imperative style of iterating over every element, we can use the so-called declarative style of using this for each operation. For each is a function, is a method that is built in our array object, and this function actually receives another function as an argument. And I'm going to use the arrow function syntax to highlight that. So this is a function, and it will provide each element of this array as an argument. We can call that a to-do to this function, and then you can use this argument to do whatever you want to do. For example, you can just print it out. In our case, we actually want to, rather than printing it out to the console, for example, we want to go and display it on the UI. So all of this, right, can be taken out of this loop, and now this statement and this construct are basically the same thing. So whatever I was doing here, I can come and do it inside the body of this function, right, and take this loop out. Okay, so the app is still the same. It works exactly the same. That, by the way, is the idea of refactoring. Refactoring means that you change the code, whether it's a structure, a style of code, without changing the behavior of the application. Okay, so I refactor my code. And again, as I said, there's no reason to do it this way other than just to show you the different styles that something can be done. Now notice what is being done here. This is a function, right? This is a function, and I can just take this out and define it as a function. So I can define it as a function like here. And what is it that I'm doing? Well, I'm creating to-do items, something like that. Actually, I'm doing it for each item. So creating to-do item, and it kind of looks like this. Well, that's the to-do, right? You can take this out, and then you can just pass this function here, and it still works the same, right? So this further notes some of interesting stuff that you see in functional programming, like you can define a function inside another function, you can pass a function to another function, right? And again, this is a regular declaration of the function, which I've been using a lot. Another way that you can define this is by taking the name off and making this an anonymous function, and then you can just store it in a variable, create to-do item, And now this variable works just like a function, right? So again, not needed to do that. This seems silly, but just showing you different styles. So this is now, because it doesn't have a name, it's an anonymous function, and this whole thing is called a function expression because this looks like an expression. There's an equal sign in here, right? Like you're assigning something, but what you're assigning is a function. So functions are values in JavaScript, just like any other value, and that enables us to pass them around, return them from function, nest them in other function, and that gives rise to a lot of different functional programming paradigm. And moving from an anonymous function to an arrow function is just this, right? And this is a slightly more compact version of defining the same thing, and it's particularly helpful if like you want to inline it. So I can like take this up, which was the original way that I was writing the for each. Okay, so let's do a few other things here. One of the things that is common in functional programming is functional composition, where you go and break something down into several functions and you kind of like build it back up by relying on those functions, like composing them together. So like when I look at this is like 3 different things that's happening here, right? This is the part that I actually create a to-do item, so this should stay here, but this is maybe something that I need to take it out. And so I can say create to-do text, maybe. Right, so pass the to-do, and then so the to-do item, this is not available here, right? So maybe we can bring this up and put it here, and instead return the to-do text, right? And so here I can go and create a to-do text, pass the to-do, right? Okay. Still everything is the same. We can do something similar here. Grab this, bring it out, const create to do input, right? So to do goes in, this comes up here, so create to do input, and we should make sure to return the element that we created. Okay. So, I mean, these names debatable, maybe create to-do div, create to-do item, create to-do element, whatever, it might be a better name for this. But so we've got basically this function that creates the text element, and this one creates the input element, and this one creates the parent component that has both of them. And even this, we can bring it out. So like I can do to do and go over here and do this, send the actual to do to it. Oops, gotta return the to do item. Okay, now everything is the same. An unnecessary refactoring here just to show you this thing exists. You can do append and like give both of them, right? Same thing. If this is just a one-liner, you don't really need to put it in curly bracket. But I want to show you actually something different, which might be more interesting. So you see, what I'm doing is that I'm getting the filtered to-dos, and sort of it's like this. The filtered to-dos like goes into a process, right? So something happens, like a function. And what comes out of it is basically these to-do items, right? So then to-do items come out of it, right? This is the process. So it's sort of a mapping, right? So it might be nicer to write it this way. You say to-do items, and then go and say filter to-do dot map, and then we can pass like, well, we can make a function and just call create to do, pass the to do, right? And then just go over here and get these and do something similar to here. Change this to append, and there you go. So everything is the same. And by the way, if that's what all we're doing is taking the to do, passing it as an argument to this function, then here is a more concise way of writing it. Right, so let's take a look at this. This is getting interesting, right? So I've got like these more focused function. The function is very clear. It creates a to-do text, creates a to-do input, creates a to-do item which contains these two, right? So this kind of calls these two elements, passes hands down the to-do. Each function is responsible to create its own element and then return it, do whatever styling, attribute, whatever stuff that needs to be done here. And now I have this function that kind of creates, it's sort of like a pipeline, a factory, a mapping process that eats the to-do and spits out this to-do div, right? And I can kind of put it here to be consumed by the map, because that's what the map does, right? The map takes every element here, it applies some function to that element, and it returns it as a new item, right? It creates a mapping. So I end up with, like, I start with an array of to-do objects, and I end up with an array of HTML elements, and then I just spread them and add them into the to-do list of elements. So this is interesting to say the least, right? And that's just the beginning. So make sure this is saved, everything works as before, and we're gonna continue exploring more and more of some of the style of functional programming and change our code and see how it works and behaves.